will understand the difference between experimental and theoretical probability. This is actually 2 lessons at 16.3 and 16.4, but because I kind of went rogue and did those activities with you, I can bring those into the conversation, and I think you'll understand the difference between theoretical and experimental. It's actually pretty simple. So let's look at, first of all, I want you to look at the next slide, and I want you to go ahead and complete this. This would be a review kind of over what we've been doing. There's 6 different questions here that they're asking you to find the probability. So go ahead right now and answer those 6, and then we'll check them.
Do you use like percentages or just?
And then reduce is 1/4. So we have 3/8, 1/8, 1/4. We've already said this one is correct at 1. This one's correct at 0. What about blue with an odd number?
2 out of 3.
2 out of how many?
3.
Out of 8, right? Because here is blue odd. So it's 2 out of 8, which is 1/4. Means you have a 1 in 4 chance of getting that. Okay. All right. All of these are called theoretical probability. This is what should happen in theory. If I spin the spinner 4 times, I should land on a blue with an odd number 1 of those 4. That's what that means. Is that truly what would happen?
That's just what they think. Most likely.
That's what's most likely to happen, okay? But, so this is theoretical. What would happen in an experiment is called experimental. So our experiments would have been, remember when we were playing the remove 1 game? And I would spin the 2 dice? That was the experiment. What did we find out happened a lot of the times during our experiments? Yeah, we got 7s a lot, we got 8s a lot, we got 6s a lot. And so then what did we do? We went over and created that chart. Remember we created the chart and we wrote all the numbers in?
Yeah.
And then we looked at it. And what did we see when we looked at it?
7.
That 7 occurs the most, and we figured out the probability was 0.17. That is theoretical. It should happen about 17% of the time we should hit a 7. Is that what really happened when we played the game? No, I mean it hit a lot, but did it hit exactly 17% of the time? No. So that's experimental. Theoretical is what should happen in theory. Okay? So let's look at some other examples of that. All right. I like this example. Okay, so here's kind of your note slide. Talks about theoretical probability, and then it shows you a picture of 2 babies. Okay? And it says the chance of having a girl or a boy should be exactly 50%, right? I mean, because you either have a girl or a boy, or an alien, but we're hoping it's just a girl or a boy. So that's your only chance, okay? But then there's experimental probability, right? And no one should be experimenting with this probability. So I've got one for you. So this is the data of an experiment, okay? So this says, what is the probability of getting a boy in real life, okay? So in this particular year, I don't know which year it is, there were this many boys born. So 2,110,558. Out of how many total births were there that year? 1,138,349. Okay, so if I take this number divided by this number, I get this on my calculator. Okay, and it's hard to see that, I know, but that says 0.51. So what does that mean? 51% were boys.
No way.
That's the experimental probability, because that's what really happened. But the theoretical is that it should be an equal chance of having a boy or girl. Does that make sense? That's the difference between the 2. One is what really happens, one is what should happen. Okay? All right.
In science last year,
Uh-huh.
we were like discussing like the probabilities
Yeah.
of having a boy or girl.
Uh-huh.
And like he like broke it down in like to DNA terms. It's like if your like mom has like this like kind of genes.
Oh, like into genetics?
Yeah, it was really fascinating.
It was really fascinating. Good. I know you'll do some more stuff with genes with Mr. Mabry. I think it's your 8th grade year. And yeah, it's kind of interesting. All right, so this part, let's classify each as experimental or theoretical probability. So A, a soccer player took 12 shots on a goal and scored once. Is that experimental or theoretical?
Experiment.
That's experimental. He was actually out in the game, making shots. He got 1 out of 12. That's an experiment. Okay? All right, next one. You roll a standard number cube 50 times and get 8 threes.
Experimental.
Yeah, that's experimental. You were rolling the number cube and you got 8 threes. 8 out of 50 would totally be experimental. Okay? Next one, you choose one tulip at random from the vase. The probability of getting red is 5 out of 12. That's theoretical, right? Because here's your picture, and the picture shows that you have 5 tulips that are red out of 12 total. That means that is the theoretical you should get. If you picked them out 12 times and put them back, 5 of those times should be exactly red. Okay, that's what should happen. All right, I'd like you to look at slide number 7. And I want you to read through those and answer that question, and then we'll talk about it. Jake? First one and the third one, good. Because number 1 says an eye doctor examines 10 people and finds that 4 are colorblind. That's just a complete experiment he's tried. I have no idea how many people are colorblind in the world, but I hope it's not 4 out of 10. Because what percent would that be?
40.
That'd be 40%. I don't think 40% of humans are colorblind, but I don't know that. Okay. All right, and then number 3, you check 6 boxes of cereal and find that 1 box has a prize at the bottom. That's totally experimental, right? Like, you don't know what the probability is because you don't know how many prizes they put in boxes. Maybe they put 1 prize in every 20 boxes and you just got lucky and found the one that had it. So that's experimental. The one that's not is number 2. A teacher chooses 1 student at random from a class of 13 boys and 12 girls. This would be the total number of kids in the class. This would be the total number that are boys. That's what should happen in theory. That it's 13 out of 25. Okay, questions before I have you work one more slide? All right, go ahead. Now, number 8 is going to combine everything we've done today. So see if you can go ahead and complete that slide. All right, so first one says, what is the experimental probability of getting heads? What would you write, Kari?
Like 50%.
On the experimental, this is you performed an experiment. Okay. Harper? Well, what would be the probability? Okay. Cooper?
It would be 35 out of 48 because they did it 48 times, so they got 35 times heads.
Right, it's right here. So 35 times came up heads, so it's 35 out of 48. And that does not reduce, so we would leave it like that. Now, if you wanted to take it a step further and change it into percent, that's okay. But you need to have that probability part. So, Harper, what did you say the percentage was? 72. Is it 72 or 73? Did you round correctly?
Oh, no, I didn't know.
Okay. So 73%. Okay. Now, that tells us automatically that, hey, that's kind of weird because on the next one it says, what is the theoretical probability of getting heads? Who have I feel like I've called on Jake a lot. Anybody else want to answer? I bet Javier knows. What is the theoretical probability of getting heads? Yeah, you do. Look at your board. Look at your screen. What'd you write? What'd you write? The 1 out of 2, which is 50%. And that's when we should say, well, hold on, that's kind of weird because they flipped it and it happened 73% of the time. It really should only happen 50% of the time. What do you think should happen the more times you perform the experiment? Like, let's say I performed it 5 times versus 5,000 times. What would you expect? You're going to get more accurate. You're going to get closer to that 50%. Okay. All right, the next one. You've got the same number of boys and girls. A student is chosen at random to raise the flag. How many times is it expected that a boy will raise the flag over 42 days of school? What do you think? Marilyn? Which would be how many? 21 times. Yes, agreed. Because you have the exact same number. So you would expect it should be about half of that number. Okay, questions on any of that?